Okay, well, so now we are moving to a really very touching and important part of every forum, and that's the award ceremony. And we're going to be presenting in this order the Susan M. Niebur Award, the Angioletta Corradini Award, the Michael WARGO Award, and the Eugene Shoemaker Medal. And I'm going to share the stage with Brian Day and Kristina Gibbs from the SSERVI Central Office in reading the descriptions of the awards, and then the bios of the awardees, and just to share just a couple of minutes of the process. These are awards that are nominated by the community, all of you. And I think that that's one of the things that that makes these so important. And I you know, as always, the awardees this year are incredibly deserving. My one regret is the same as with all meetings now, is that I can't give hugs and shake hands in person. But that doesn't negate at all the importance of these. And so congratulations in advance to everyone. We have detailed descriptions on our website that a lot of you I know have seen already. But if you miss any of this, please feel free to go over and check these out. And then thanks to Jen Baer on the SSERVI staff, the awards were actually sent out to all of the awardees early, so they should have them now, mail notwithstanding. And finally, I'd like to ask that all of the awardees stay for the entire ceremony so that we can do a group photo at the end. So with that, let me move to my my file here, and I am going to take the first two, and that's the Susan Mahan Niebur Early Career Award. And so this award is an annual award given to an early career scientist who's made significant contributions to the science or explorations communities. Recipients of this award are researchers who are no more than 10 years from receiving their doctorate degrees and who have shown excellence in their field and demonstrated meaningful contributions to the science and/or exploration communities. Susan Mahan Niebur, who passed away in 2012, was a former Discovery Program scientist at NASA who initiated the first ever Early Career Fellowship and the annual Early Career Workshop to help new planetary scientists break into the field. This year, the prize is awarded to two very deserving people, Amy Fagan, Professor Amy Fagan, and Dr. Ryan Watkins. And I want to give a special shout out here to Kurt Niebur, who I believe is online and listening to this. So we're going to start with Professor Amy Fagan, who received her BS in geology with honors from Washington and Lee University in 2006, and her PhD in lunar petrology from University of Notre Dame in 2013. Professor Fagan's doctoral research under the guidance of Dr. Clive Neal focused on volcanic and impact processes on Mars and the Moon. Using MOLA data, she examined the morphology of impact craters and subglacial volcanoes on Mars's surface, while the bulk of her research examined the chemical composition of Apollo basalts and impact melt products. In 2009, she was a lunar exploration student intern supervised by Dr. David Kring, one of the SSERVI PIs, as part of SSERVI's Center for Lunar Science and Exploration team, quickly rising to the level of graduate student researcher and then a postdoctoral fellow. In 2012, she received the Lunar and Planetary Institute Career Development Award. Her service to the professional activities of this community have been exemplary. She served on several NASA Science Mission Directorate review panels as a NASA Lunar Exploration Analysis Group member and operations chair, a COSPAR Rapid Response Specific Action Team member, an LPSC co-chair, an NESF co-organizer, session co-chair, panel member, and many, many other things. Dr. Fagan is now Associate Professor in the Geosciences and Natural Resources Department at Western Carolina University, and is currently involved with the same effort that we heard about earlier on Apollo samples. SSERVI is very honored to present the Susan Niebur Award to Professor Fagan. Amy, please take it away.
Thank you, Greg. I'm gonna see if I can share my screen here. Can y'all hear me okay?
Yes.
Awesome. Can you see my main slide?
Yes, yes.
Fantastic. It's a good day. So thank you, Greg, for that introduction. It is.
Uh-oh. Did it freeze for anyone else?
I cannot hear her any longer.
Okay, I will text her. I will text her. We were texting.
Maybe come back to her.
I guess my internet went out. Can you hear me?
Yes, now I can. Yeah, okay. Thank you.
Sorry, I live in the mountains of Western North Carolina, and sometimes our internet can be a little spotty. So hopefully this will work.
No
anyways,
problem.
Back in 2014, I wondered what I would talk about if I ever won this award. And I thought that mentoring was one of the most important things that had helped me on my career path. And so that's what I would talk about someday if I ever won it. And then, of course, my friend Noah Petro stole that topic in 2016, but I forgive him. And I think it's still important to talk about. So I'm going to talk about mentoring today. Let's see. I never met Susan Niebur, but I know a lot of people who knew her personally and spoke very warmly of her. And when I found out I was going to receive this award, I wanted to find a way to honor her legacy. And so I've included this quote that a lot of people include from her, that all that survives after our death are publications and people. So look carefully after the words you write, the thoughts and publications you create, and how you love others. For these are the only things that will remain. And there's one thing in here that I really want to focus on, and it's people. The people in our community are really important to us, and taking care of those people are important. And that's where mentoring is going to tie into this. But there was still one thing that I was really wanting to focus on in terms of honoring Susan's legacy, that I wasn't sure that mentoring was quite enough. And so I went to her blog, Toddler Planet, and the last blog after she passed away. And furthering Susan's through a contribution to the Inflammatory Breast Cancer Research Foundation, or please choose to make a difference somewhere, anywhere, to anyone. And Ryan and I have talked about this, Ryan Watkins and I have talked about this, and we're both going to make a contribution in Susan's name to the Inflammatory Breast Cancer Research Foundation. I encourage anyone who knew Susan or feels compelled to honor her legacy to do the same. But the other part really captures, again, what Susan said, that making a difference somewhere, anywhere, to anyone, and that's where mentoring comes in. So mentoring is the key to how we grow and we succeed, and it starts very, very early. This is kind of my envisionment of how mentoring has worked for me. It starts off with family. They give you your first values, teach you important lessons like how to do a proper handshake, which right now might not be the best life skill due to COVID, but it's maybe going to come back at some point. Friends and family. Friends teach you how to meet other people, which for some of us can be very difficult. And then school teachers, your first taste of education and looking for answers. And I know for a lot of us, we really got into science when we were young, and it was an elementary school teacher or a middle school teacher or high school teacher who really made a difference. But it's not just in the classroom. one of the most important lessons that I learned from a mentor was from my algebra teacher in high school, Mr. Simmons. I was talking to him one day in the office, and most of you who know me would probably be shocked to know that when I was a child, I was terribly shy, painfully shy, could not talk to people. So I was talking to him in the office, and in my typical way, I was mostly staring at the floor. And he stopped me mid-sentence and he said, Amy, when you talk to somebody, look at them in their eyes. And it was such a simple piece of advice, but no one had ever told me. And after that, I really worked hard to incorporate that into any time I was talking to somebody. So think back, actually, it's interesting of what important lessons you learned from your school teachers. From your coaches, hopefully you learned how to fail with grace and to succeed with class, and also to work together. College professors help to teach you more about your field. Some of you may have gone to college thinking you were going to major in one thing, and there was one class that made a difference, and now you're here in this field. So they really play an important key role. But the two that I want to focus on the most are graduate school advisors and postdoc advisors, because for me, they've played some of the most important roles in mentoring. My graduate school advisor was Clive Neal, postdoc advisor David Crane. And from the two of them, so many lessons. One, that the scientific method that you were taught as a child is not as simple as what you were taught. My writing needed improvement. My public speaking needed improvement. Working independently needed improvement. Working together as a group needed improvement. And my networking skills needed to improve. And they helped me to do that. There is no way that I would be sitting here talking to y'all from the bonus room above my garage today if it weren't for those two people. And one thing I want to highlight is that they're very, very different people. They have different perspectives. They have different strengths. But I need both of them. They both support me, and they have a vested interest in my success, and they have no problem telling me when I need to buckle down. And they're also the first ones to congratulate me when I do something well. You need people of various different backgrounds to help you and be your mentors. It's difficult to have one person cover all your bases. So for the students and the early career people listening, I encourage you to seek out other people to supplement your advisors. The last one I want to point out are colleagues. These can be people of various different generations, teaching you how to network, teaching you that maybe you shouldn't be using those two colors, because if you're colorblind, you won't be able to tell the difference between the symbols. There are many colleagues that have really helped me get to where I am right now. But as with any flower, you need to have water and you need to have sunlight to grow. So this is my advice for mentors, because this was the most important thing to me. For mentors, please introduce your mentees to your colleagues. This is the most important thing that David and Clive did for me when I was working with them, and they still introduce me to new people. If I hadn't been introduced to all these different people, there's no way I would be talking to you today. They played a key role in getting me where I am today. For mentees, it's not all the work on the mentor. Mentoring is hard. Tell your mentor what you want to be. I was always upfront with David and Clive that I wanted to teach, and they were always very supportive of that. But if I hadn't told them that, they wouldn't have been able to give me advice about it. So tell your mentor what you want to be. It is helpful. And eventually you'll have seeds of advice that you will spread out to people, and your mentors will be giving their advice through you. So it's an important relationship that needs to be cultivated. Sometimes it goes awry. There's a lot of resources out there about mentoring. This is a recent one that covered some of the problems that have come up in mentoring, specifically with undergraduates, but I think we've all probably encountered one of these at some point in the past. I'm not going to dwell on this, except to say that there are some areas for improvement. But the one thing I want to point out is absenteeism, that this was pointed out as one of the major negative mentoring experiences. And during the global health crisis, we're all encountering this. So please take a moment today and reach out to your mentors. Mentors reach out to your mentees and check on them, because when we're absent from each other, it's hard. So take care of your people. The good news, though, is that there are always resources to improve. One recent paper looked at 3 really simple tasks of how to improve your mentorship. One was taking cues from research on parent-child relationships. Oftentimes, the dynamic between a mentor and a mentee is very similar than that of a parent and child. Tell your students you believe in them and that you're helping them to reach their full potential. Often when you get only negative feedback, even if it's meant to be constructive, it can be hard. So tell them that you're working with them to improve. And the last one is helping your mentees embrace failure as growth. We sit in the audience or stare at our computer in this case and see all these people who are so successful. And it's really hard to put yourself in those shoes when you might be having failures. And it's important for people to know that anyone who is in this field has had so many failures, but they're just hidden. So if you fail at something, take that as a lesson and don't dwell on it. I'm terrible at dwelling on failures, but use it as growth and recognize that everybody here has failed as well. The second resource is actually from the National Academies Press, and it's a recent report that gives you a lot of resources of how to improve your mentorship. It talks about why mentorship is important and gives you recommendations and tools to help succeed. So I encourage you to go to that website. I have it listed here below, but I can also put it in the chat box as well. So my last slide is to, again, encourage everyone to take care of each other. And by doing so, you're going to need to embrace and expand your mentoring repertoire. For mentors, please introduce your mentees to your colleagues. It really is the single most important thing that my mentors have done for me. Ask your students and your early career mentees what their career plans are. They might not know yet. You can help them figure it out. For students and early career scientists, tell your mentor what you want. They cannot read your mind. And also recognize that network opportunities are really important. Seek them out. And that you never can have too many mentors. One place that you can find those networking opportunities and potential mentors is through the next generation of lunar scientists and engineers, which Ryan Watkins is going to be talking about next. I've included the web link here, but I also want to put myself out there as an alternative mentor. If you want to know about teaching at a predominantly undergraduate institution, reach out to me. I've included my email address. If you want to know about being in this career with kids, reach out to me. I've included my email address. I'm very, very open about talking about these topics. So I'm offering my services to you. Don't be afraid, reach out. And then to everyone, I want to remind you that there are resources to help you improve. Mentoring and actually improving our mentoring techniques is not something we often talk about, but it's there, it's important to everyone, and it helps to bind us together. So check out that webpage on the National Academies Press and see what you can get from it. So that's all I have, except to leave you with this quote again from Susan Niebur, and to remind you to take care of your people. And thank you to those who have mentored me. Without you, I would not have given this talk today, and it means the world to me. Thank you, Greg. That's all I have.
Wow, Amy, thank you. You're getting me all choked up here. This is
my job is done then.
Take care of each other. What a great theme. You know, I think that should be the theme for this entire meeting, quite frankly. So I love it. What a wonderful talk. I don't think I can add anything beyond that. Thank you so much, and congratulations again.
Thank you, Greg.
So I'd like to next introduce Dr. Ryan Watkins. Dr. Watkins' research focuses on integrating remote sensing data sets to characterize the physical and compositional properties of airless bodies, with particular emphasis on the lunar surface. She specializes in using photometry to understand physical and compositional properties of the lunar surface and in integrating planetary data sets to assess landing site safety hazards for future missions. Dr. Watkins obtained dual BS degrees in physics and space science from the Florida Institute of Technology in 2010 and her PhD in Earth and Planetary Science from Washington University in St. Louis in 2015. Before joining PSI as a research scientist, she served as a postdoctoral research associate at WashU in St. Louis with Dr. Bradley Jolliffe, who you'll be hearing from later. Dr. Watkins is actively engaged in service and leadership within the planetary science community. She serves on the organizing committee for the Next Gen Lunar Scientists and Engineers group that Amy just mentioned, on the executive committee for the Lunar Exploration Analysis Group, League, on the steering committee for the Equity, Diversity, and Inclusion Working Group, and on Blue Origin's Science Advisory Board for their Blue Moon Lander project. In addition to research and planetary community service, Dr. Watkins regularly participates in education and public outreach in her local community and with the Solar System Exploration Virtual Research, SSERVI, Toolbox for Research and Exploration Treks team. SSERVI is very pleased to present the Susan Niebur Award to Dr. Brian Watkins. Brian, please take it away.
All right, are you seeing my slide?
Yes, and we can hear you.
Yeah, so again, thanks Greg, and thanks SSERVI. So I will talk for a few minutes. A lot of people know me primarily because of my involvement with the Next Gen group. So I want to spend the next few minutes talking about my vision for the future of the Next Gen, not so much from an organizational point of view, but more from a personal and professional point of view. Before I do that though, I just want to put out a few thank yous to key players along my journey. First and foremost being my family, my parents who are always supportive and encouraged me to pursue my dreams, even if that meant moving far away from them, which I know is difficult. And also for my husband who supported me through every step, including probably doing the crazy act of marrying me 2 months before I defended my PhD. But they have always been there to support me and cheer me on. And kind of like, Amy mentioned, I've had some very great mentors in my life, and I want to call out 2 of them specifically here. First off, being Phil Metzger. I want to thank Phil for giving me my very first research opportunities. Honestly, without those, I don't know that I would be here where I am today. So I want to thank him for always being willing to lay on the floor in buildings to get very cool pictures, as you can see up here. And for just countless conversations and adventures that I will never forget. And then second, my PhD advisor, Brad Jolliffe. I want to thank him for the opportunities he gave me. Like Amy said, he was one of those people that introduced me to his colleagues, and that really made a big difference in my career. Also, thank you for bringing me on to Moonrise before I was even a student. That really laid some of the foundations for where I would go in the future. To being crazy enough to keep me around for a postdoc after I graduated while I secured my own independent funding through PSI, and always looking out for me, and also for knowing the proper way to position me to actually maybe look like I'm a geologist, even though I'm not. And then I also want to thank my support network. So this support network, it fluctuates with time. People come in and out of it. But I just want to call out 4 people who have been really key just over the last couple of years, and especially during this pandemic. These are people who are there to talk science, to talk life, and everything in between. They're the people who encourage me to take a break, go get chocolate or whatever I need to do. I highly recommend getting yourself a group of friends that you can send weekly to-do lists to, who help keep you accountable for meeting your goals, who encourage you, again, to take breaks and to not get too hard on yourself if you maybe don't meet one of your goals. So these are Sarah Valencia, Lillian Ostrach, Erica Jawin, and Lauren. And sorry, Erica and Lauren, I didn't have really great pictures of you. And I didn't want to just steal any off the internet without asking, but you are very much appreciated. And then finally, I want to thank, obviously, Susan Niebur, who I unfortunately never had the privilege of knowing, but she was a strong advocate for early career scientists, women, and families in science, which are all topics I care very much about. Her passion, strength, and courage really shone through her words. I spent a lot of time reading her blog this past week. It was obvious that in the midst of her suffering, she was always helping others, and I just wish I'd had the chance to cross paths with her. And then again, thank you to SSERVI and League for the support of Next Gen, and several other people I've listed here that have been key players in my career. So I'll move into trying to quickly talk about kind of my vision for what the next gen looks like. So the first thing I want to talk about is I want the next gen to be passionate. So in our statement about who we are, we define the next gen as an assemblage of grad students, postdocs, and early career scientists who have a passion and vision for lunar science and exploration. And these aren't words that we use lightly. So anyone can look up at the moon in awe, but only those with a true passion for uncovering the mysteries and secrets it holds can truly pave the way for a sustainable return. And I'm talking here about, the next gen lunar group, but these traits are all applicable for other areas of planetary science as well. I also want them to be diverse. So there's a lot to untangle in the word diverse, and I don't have time to detail every element of diversity that our field needs, but I think most of us are all too aware that our field is too white. We need more Black scientists, more brown scientists, just a wider range of ethnicities, more underrepresented groups in general. We need more people of different social identities, different cultures, different backgrounds that are historically overlooked or marginalized. And I'm not intentionally leaving any one group out here. Obviously, I don't have time to name all of them in one PowerPoint slide in about 30 seconds, but know that if you have skin on your bones, we need you in our field. And I recognize, my privilege as I try to address this issue again in 30 seconds. And I'm not perfect, but I am committed to staying informed and aware. And it is my hope and desire that the next gen does the same and continues to be outspoken on these issues, and not just outspoken, but active in doing things to change the direction of our field. And I won't spend a lot of time on this element since Amy just covered it very well, but I do want the next gen to be well mentored. It's possible to be successful without having a good mentor, but quality mentoring just truly enhances the chances for success. And again, I won't belabor this. You can go back and rewatch Amy's talk if you want to hear more about it. I also want them to be well funded. So there are a few programs that exist to financially support early career scientists as we essentially get on our feet after completing our PhDs or postdocs. Susan obviously did a lot to get this started, but soft money early career scientists are often just thrown into competition pools with more experienced scientists. And this isn't saying that we can't write a good proposal or do good science or get funding, but it's just a plain fact that implicit bias exists in our review system, and that name recognition often unintentionally leads to higher funding rates for more established scientists. So I really think we need more programs dedicated to funding early career scientists who do not necessarily rely on successful PI-led proposals being selected or being competed against the rest of the community. And these kinds of programs need to be open for all early career scientists, regardless of their institution type or their career trajectory, which I think is another important element. I also want the next gen to be accountable. And what do I mean by accountable? It means acknowledging when we make mistakes, whether it's professionally, socially, or culturally. It means accepting responsibility, holding higher positions within our field that obligate us to advocate for continued lunar exploration. It means taking it upon ourselves to ensure that the US has a robust and sustainable lunar exploration program, and to make sure that the planetary science community continues to welcome all people. It also means learning from our mistakes, knowing how to receive constructive criticism, and knowing when to step back and let others take the lead. And finally, I want the next gen to feel that they belong. And this doesn't mean only belonging to a community with a shared vision, but belonging to a sense of a higher purpose of moving beyond our planet so that we can understand our planet. And a higher purpose of again, advocating for underrepresented groups, a higher purpose of inspiring students and the general public. So what can we do to support the next gen? First off, let them have other identities beyond just scientists or students. Let them be parents, let them be athletes, whatever it is that fits in their kind of definition of their other identities, like let them be that and support them in that. Foster work-life balance. We could spend a whole hour talking just about that, but there does need to be more support for this work-life balance. Invite them onto mission teams, committees, proposals, strategic action teams, etc. I know League and SSERVI have done a great job at this, but there is still room for improvement within the community. Value their time. Don't just assume that because they're early career that they're not busy or they're not committed to things. Obviously, again, invite them to do things, but if they say no because they just don't have the time, like, respect that. It's not something to shame them for. And value their contributions. Just because they're early career doesn't mean they don't have things worth of value to contribute, again, to your team, to your committee, to your proposal. And finally, just speak up for them. We need the voices of the more established scientists behind us. And this slide is partly an excuse just to show pictures of my adorable children, but it's also, I just want to say that there are a lot of reasons that I care about early career scientists and the next gen. Again, they're the future of our field. We need to support them as they step into their roles to lead us back to the moon. But I also care because I'm raising the next gen, whether they're next gen, lunar scientists or not. These traits that I've mentioned are things I want them to be. I want them to be passionate. I want them to care about diversity, to be accountable, to be well mentored throughout their lives, and just to feel like they belong in whatever elements that they may go into. So I want others to value them, and I want them to see that hopefully their mother did all she could to advocate for them and for others, much of the way Susan Niebur did. And I just kind of want to end it on that note again with a little tribute to Susan and a big thank you for all that she did to support early career scientists. So again, thank you, Greg, and thank you, SSERVI.
And thank you, Ryan. And what a wonderful talk. Two wonderful talks. I just take so much out of what both of you said, and what a privilege it is for me personally to have been able to work with you, Ryan, and you, Amy. I'll just share the very quick story that Clive and I chaired a certain workshop a couple of years ago, and as you well remember, and you, Sarah and Erica, were the people that I would say made the workshop a success. Is really the bottom line, and I've been telling everyone that I have every confidence in the next generation, and for me, I consider that helping the next generation is the most important thing I do, and I know a lot of other people who feel exactly the same. So anyway, what an honor it is to bestow these awards on two such deserving people. So thank you so much. I'm going to turn it over now to Brian Day to introduce the next awardee.
Thank you, Greg. The SSERVI Angeletta Corradini Mid-Career Award is given annually to a mid-career scientist for broad, lasting accomplishments related to SSERVI fields of interest. Angeletta Corradini, who was with us from 1946 through 2011, was an Italian planetary scientist who has inspired astronomers around the world. The 2019 Angeletta Corradini Mid-Career Award is given to Dr. Harold Hiesinger, Professor of Geological Planetology at the University of Münster in Germany. Professor Hiesinger is a person known for his curiosity. He enjoys finding out how things work. He is a member of both the American and European Geophysical Unions and the Geologic Society of America. He has been recognized with multiple achievement awards from the European Space Agency and has received NASA Group Achievement Awards as part of the Dawn Mission Science Team and the Lunar Reconnaissance Orbiter Team. He is a participating scientist for ExoMars and JUICE, two upcoming ESA missions to Mars and the Jupiter system. In 2014, the International Astronomical Union named asteroid 26811 Hiesinger after him. He has been a strong collaborator with SSERVI teams. His research into planetary processes and the geologic evolution of terrestrial planets and moons has advanced our understanding of the lunar chronology and helped constrain the age of the South Pole Aitken Basin and other potential lunar landing sites. He recently detailed mission preparations for commercial in situ resource utilization demonstration and is engaged in a wide array of other projects, including astronaut training. After 30 years in planetary sciences, he still loves his job and hopes to play a role in returning astronauts to the moon and beyond. I'm sure he will. In addition to being widely published and credited with numerous journal articles, his many contributions and achievements make him a worthy recipient of the 2020 Angioletta Corradini Mid-Career Award. Herzlichen Glückwunsch, mein Freund. Sie verdienen diese Auszeichnung. Doch. Congratulations, Harry.
Thank you very, very much, Brian. So I hope you can see my presentation now.
Not quite yet.
Can you not see it?
I can see it, but it's in slide.
Okay.
There we go.
There we go.
We
Okay.
see the presenter view, Harry.
Pardon? The presenter view. Oh,
Yeah.
how do I do this then?
Yeah, within PowerPoint.
You can go and swap displays.
Does
Yeah,
this help? Okay.
that's perfect.
All right, sorry for this. So what I'm gonna try to do is sort of, yeah, a little bit of retrospective things, and then also, of course, some forward-looking. So I try to give you a personal mid-career reflection. Before I do this, of course, I would like to thank a couple of people. First of all, of course, the Corradini family. I've known actually Angioletta a little bit, okay, when I was a young graduate student. She often visited Gerhard Neukum, one of my mentors and advisor. And of course, we weren't really talking to each other because she was basically playing in the major league, really advancing planetary sciences in Europe quite a bit, whereas I was basically as a young graduate student playing rookie league. So, but I can tell you that Gerhard Neukum really respected her because she was a very influential person, very straightforward, and just a great advocate for planetary sciences in Europe. I would also like to thank, of course, SSERVI for handing me this award. And as Greg said in the beginning, you know, the nominations come from you. So thank you, all my colleagues, all my friends, and I have hopefully many of those among you. And of course, also my mentors. And not the last, you know, of course, thanks to Carolyn and my two kids that sort of have to live with that I'm gone for quite a while, and of course also my dad and my mom. So mentors, yes, very, very important. I had the luck that I had really three very influential, very, very great mentors. First of all, Gerhard Neukum, that many of you know. He taught me that you have to fight for the things that you really want and you cannot let go before you get what you want, okay? And he also was brave enough to stand up for his opinions and tell people that they are wrong, okay? This is one of the famous quotes that a lot of you probably have in mind when you think about Gerhard Neukum. And I think this is really, really important. And of course, Ralf Jaumann, who involved me or got me the chance to be part of many, many space missions, who actually helped me with writing my thesis, you know, by commenting on early drafts and so forth. And finally, Jim Head, you know, who opened an entire new universe for me when I was able to work for him for a couple of years. So thank you all. And also thank you to all the other people that who inspired me. So if you are at the beginning of your career, you have to make a couple of choices. And I would like to start out with this poem by Robert Frost from 1916, where he describes basically two guys that go down a wooded pathway and then come to a junction. And so you have to make a decision. And when you look down the pathways, yeah, you cannot look all the way to their end. You cannot look into the future too much, but nevertheless, you have to make a decision. And so the really important part that sort of comes close to what I'm doing or what I was experiencing is, are the last three lines. Two roads diverged in a wood, and I took the one less traveled by, and that has made all the difference. Okay, so let's look at a little bit in my career, what were actually the choices and the paths that I took. So here you see me, that's me here, okay, close to a keg of excellent Bavarian beer. So the first choice would have been to become an alcoholic, you know, having access to lots of excellent beer. But I did not take this road and instead took another road. So for a long time as a little kid, I thought I would become a caterpillar driver in Africa. Well, that didn't really materialize. And then after that first career end, you know, I had really for a long time no idea what I should do. So through my entire high school career, I just didn't think about what I want to do. And then all of a sudden, the second career, going to high school, was over. So then what to do? Well, I decided to become an Air Force officer. So I went to the test, failed it miserably. So I have it now in writing that I'm too stupid to be a German Air Force officer. So that's something that you have to stand up again and move on. So then I thought, maybe it's a cool thing to become a veterinarian. But there, my high school grades were not good enough. So that was also a very short career. And so finally, I started studying geology at the University of Munich, and I loved it from day on, from the first day on. So at the end, you know, I tried to get the PhD in ore mining, but there was no funding in this. So that's how I ended up in planetary sciences. So I'm clearly the kid that did not dream about becoming a planetary scientist from this age on, but came to the business fairly late. Then, of course, at some point you have to decide, and I got married. I went sailing a lot, which resulted in a very long PhD. It took me 9 years and also resulted in divorcing my first wife. So what a great time then to move to Brown. And so I met just an incredible set of people there, you know, Jim Head, Collie Peters, Pete Schultz, Jack Mustard, and of course, all the fantastic grad students that really changed my perspective. And that's when my career really, really took off. I got married with one of the Brown family members, Carolyn. Excellent choice. We are married now for 20 years, but it also meant that we got into this classical two-body problem. So Carolyn was commuting to New York. I was commuting in the other direction. That was really very, very difficult during the times when I was a professor at Central Connecticut State. And so we were both quite happy that we got the opportunity to move to Germany to the Institute for Paläontology in Münster. And so now we also have 2 kids, you know, the next gen that was just mentioned. Actually, Carolyn, of course, got the kids. And I don't know where my future will be. I cannot look down far enough the past, but I have a little coffee mug with a cartoon on it that says basically basketball, football, baseball, retirement, golf, death. So mid-career would bring me somewhere into the baseball area. But actually, if I think about it, I think I'm more like in the basketball and football league, but we will see. Okay. So a little bit about science. What are my interests? Well, a lot of people know me best probably for the work that I do on the chronology of planets, but in fact, I'm much more broadly oriented. You know, I published a number of papers on various topics, and that's one of the big lessons that I learned in my career, that you cannot build a career on just one topic and one planet. So you have to think broader. You have to expand to many different planets, work on many different topics. And that is also reflected in all these missions that I'm involved in. And what I really enjoy, what comes with all these missions is the international collaboration across any culture, across any color of your skin, across any religion. It all doesn't matter because we are all scientists, and that's just beautiful. And so also I do a lot of work on terrestrial analogs. Again, pretty much anywhere I can get to, Svalbard, the Reese Crater, China, and of course that results in a lot of publications so far. But what's also very dear to my heart is that I would like to serve the community and inspire the next generation. I'm trying hard to provide good and exciting teaching, and also what was mentioned earlier, providing a network or building bridges and providing opportunities for the next generation. And in general, promoting science, very, very dear to my heart. And Brian mentioned it, remain curious. You know, I always wonder what would happen if you could just keep the curiosity of a 5 or 6 year old across the teens, you know, when they all of a sudden it becomes uncool to ask questions. If you ask questions, you will find interesting topics and you will find interesting challenges. Okay, so just a really quick science slide just to show what we did over the last 30 years. If this is a midterm thing, if you just look at the colored surfaces, a lot of the area on the moon is still not colored. So there's still a lot of work to be done. Okay, and I guess I have to hurry up finishing all the rest of the moon by the end of my career. So let's just step back a little bit and not talk more about the science that I do, but some sort of general thoughts, you know, why I think science is important to us, why I think science matters, and how it relates to our society. So as planetologists, we are all very good in problem-solving thinking because we usually have only limited amount of data available, but still have to figure out how things work. So that makes us, in my opinion, really good leaders. So this would be this bear here, this polar bear. We might not always know where we're going exactly, but we have a good idea of our environment, of the context, if you will, and we will find out a way of different problems. Other people, politics, society, they might get into deep water, you know, and if the water is up to their necks, then in an ideal case, they would look to scientists for answers. And this was what happened over the last couple of 100 years. But nowadays, with fake news and so forth, politics and also society sort of doesn't see scientists as leaders anymore. And this is really something that concerns me and this is highly frustrating to me. And I think we need to work on this. So this is a diagram that I stole from Jim Head. It sort of shows time on the x-axis and space on the y-axis. And most people obviously are concerned about themselves. So it's all about me. You know, do I have enough bread at home? How do I get my kids to piano lesson or to soccer lesson? That's what we are usually operating in this little part of the diagram. But as planetologists, you know, we are not concerned about this. We are concerned about stuff that is up here somewhere or even beyond that. So we really have to step back and think hard what we can learn from planets that affect our planet here, our Earth, our daily life. So think big. And for that, I think you also have to leave your comfort zone. You know, you have to go out and challenge yourself. And that might be very difficult. You might get answers that you don't like, and you might have to change your personal life to save the planet, if you will. So, and that's also reflected then, of course, in this sapere aude from Horace, which means basically dare to be wise. So see the big picture. If you start or if you continue burning fossil fuels at the rate as we do now, this will end up in a very bad situation. So it's not sustainable. And that's what we need to consider and where planets can teach us. Okay. And we have to stand up. This was already mentioned before. And I just took a quote from Gene Kranz, you know, after the Apollo 1 disaster, you know, where basically says, yeah, we did not do our job. We did not stand up. So we should be, as scientists nowadays, we should be the ones that stand up and say, damn it, stop what you're doing. Okay, we are moving in the wrong direction. So tough and competent, those are the really important words. And tough here means, you know, being held accountable and never compromise your responsibilities. So we have responsibilities as scientists that we have to fulfill. And anytime we walk into mission control or anytime we talk to the press, anytime we deal with the public, we will have to know what we are standing for. Competence means that we never take anything granted and that we, you know, that we keep searching, that we educate ourselves. And so I think this is really a great quote that guides my sort of thinking. And in fact, I went into my office and I just did that. I wrote it on my blackboard or on my whiteboard actually, and it will remind me that what we as scientists stand for. So there are numerous obviously problems, big problems that we can address. Here's just a glacier in Svalbard. And we go to this area now for a couple of years. And since 2011, this glacier retreated by almost 2 kilometers. Okay, so climate change, burning fossil fuels. This is obviously a huge problem that we have to solve, that we have to address. And where even Mars or other planets might help solving us. What will happen if we get a more and more pronounced greenhouse effect here on this planet? Well, go to Venus. There you have it. You know, this is the super greenhouse planet. Mars, on the other hand, also indication for lots of climate change, maybe even more radical than what we experience right now, but the outcome is not pretty. The other question that we, of course, can address as planetologists is life. You know, how did it evolve and how did it develop? So if you look at the Earth record, we see that there were periods where lots and lots of species got extinct, some by large volcanic eruptions, some by impacts. But we only have a very sort of limited record of history, let's say the last 600 million years, where we have good record. But look at this, the entire half of this diagram is empty. Okay, so there is almost no information that we can learn from Earth. So that's where the planets help us to fill in this part of information. And when you do this, you end up at times where life actually started. Okay, and so how is the beginning of life related, for example, with the impact flux that happened early on? Is there really this spike that frustrated life very early on, or is this cataclysm not really existent? So those are really important questions that I think we need to work on. And then, so for the last couple of minutes, a little bit of outlook. Well, obviously, this is one of my favorite slides because the moon here is very prominently featured, okay? And so as a person that worked a lot on the moon, I would actually like to see that we go back to the moon. So forward to the moon, if you will, with humans. And I'm just hoping that I can play a little role in sending back humans to the moon and maybe beyond, you know, maybe at the end of my career, we will be at Mars. Sample return mission and space missions to multiple bodies. Yes, I would dream about, or I'm dreaming about this, because this is really key to understand our own planet. And all this, of course, requires a solid international space program. And I think we need some altruism in terms of international collaboration and cooperation. So I really like the "for all mankind" quote from the Apollo times. It is really for everybody on this planet. And so this is really dear to my heart. And then there are other things that are equally interesting, but the more important ones are certainly up there. And for the sake of time, I'm not really talking about this, but maybe just the improved funding and the improvement in the educational system. This is particularly in Europe extremely important because we don't have many resources. The only thing that we have in Europe are our brains, and that's where we should invest our money to get better trained students and better trained next generation scientists. And then, of course, on a personal level, I would wish for many, many more collaborations with the planetary community and the continued friendship with many of you. And of course, tons of new exciting science results. And there are tons of them out there, believe me. So that brings me to the end, basically. And I started with a poem from Robert Frost, and I would actually like to end with a poem from Robert Frost. You can read here, it's much longer, of course. This is just the last 4 lines. And I would actually like to rephrase this and put it in our contents. So science is lovely, dark, and deep, but we all have promises to keep, and miles to go before I sleep, and miles to go before I sleep. Thank you very much.
Thank you, Harry. That was wonderful. Very, very inspiring, and I appreciate it. And congratulations from me. So with that, we are running a little bit late, but these talks have been fabulous. And so we're going to carve a little bit of time off of our breaks and continue on with the awards that we have to give today, it's my pleasure to be announcing the Michael J. WARGO Science Award, Exploration Science Award. And this is an award given by SSERVI to a scientist or engineer who has significantly contributed to the integration of exploration and planetary science throughout their career. Dr. WARGO was an outgoing and strong advocate for the integration of science, engineering, and technology. He worked closely with planetary researchers, especially in the lunar and Mars science communities, to develop collaborative and highly productive missions. He also provided guidance and direction of our predecessor institute, the NASA Lunar Science Institute, and the creation of SSERVI. Dr. WARGO was a shining example of collaboration and open communication that has inspired many scientists and engineers. And so it is my pleasure to award the 2020 Michael J. WARGO Exploration Science Award to Dr. Mark Robinson. Dr. Robinson is a professor of Geologic Sciences in Arizona State University's School of Earth and Science Exploration. He is a member of the NASA Advisory Council and serves as a principal investigator for the imaging system on NASA's Lunar Reconnaissance Orbiter. LRO has collected a treasure trove of data and is making an invaluable contribution to our knowledge about Moon, as you all know well. Dr. Robinson's stewardship of this instrument has enabled numerous groundbreaking discoveries that has created a new picture of the Moon as a dynamic and complex body. Throughout his career, his investigations have used a variety of remote sensing techniques and data sets from dozens of NASA missions. He worked on the Clementine mission, which provided our first complete look at the lunar surface, including the poles, and found evidence of ice in the bottom of the permanently shadowed crater at the Moon's south pole. His collaborative research on old data resurrected from the Mariner 10 to Mercury missions extracted compositional information about the surface rocks that had laid hidden in the old data for roughly 20 years. Much of his current research efforts focus on expanding our knowledge of the lunar surface, paving the way for future human and robotic exploration of the Moon. His discoveries and research developments have set a scientific framework through which to challenge and improve our understanding of the processes throughout the solar system. With that, I'd like to congratulate you, Dr. Robinson, and offer you the floor to present your thoughts.
Okay, thank you very much for those nice words, and I will try to get the share screen to work. Okay. Pointer.
That looks great.
I'm trying to get the laser pointer here to work. Okay, cool. I think we're set.
Okay.
Okay, again, thank you very much. I'm going to talk about Mike mostly because he was an incredible force of good. And what you see in the background here is WARGO Crater, which was named for Mike 3 or 4 years ago. And I helped select the crater, and I thought it was an incredibly appropriate crater. In fact, it was our second choice because the first choice was overruled by the IAU due to some obscure, I can't remember now, it doesn't matter. But the reason I love this crater for Mike is because it's full of geologic landforms that represent what happens during these incredibly energetic events that shape the solar system, basically. And I know he would have been asking lots of questions as we, of how the crater formed and how all those landforms, and I'll get into that in a minute. But I thought this was a great picture. I remember this moment when Mike appeared on the screen at a SSERVI meeting in 2012. And we always like to laugh about it. It was the Big Head Mike talk. And it was, as usual, incredibly entertaining because that's just the kind of guy he was. But he always brought a sense of competence to whatever he was doing. And in fact, earlier today, I was sitting down here trying to think of what would be 3 words that I would use to describe Mike. And what I came up with was competent, curious, and fun. So I think that really summarizes at least my experience with Mike. I know everybody's, humans are very complex and they have all different sides. But I really think that that sums Mike up as competent, curious, and fun. And he brought that into everything that he did. And here's a picture of WARGO crater, a little, that same picture, a little background. It's 14 kilometers in diameter to give you a sense of scale. And it's superimposed on Jewel T crater. So even though WARGO crater is much smaller, it somewhat dominates this bigger crater, Jewel T. And as I was mentioning earlier, here's these amazing array of landforms that I think we're way behind. I was going to talk about them somewhat, but I think it's more fun to talk about WARGO stories. But just to give you some sense of relief, that back wall from here to there is 3,200 meters, or for those of you who don't think in meters, that's 10,000 feet tall. It's crazy big. It's a wonderful crater. And you'll see this link down here in the bottom left. While I'm talking, if you get bored, it'll be on the next several slides. You can go to Quick Map, and this will bring up WARGO crater, and you can zoom around and look at it in detail. Let's see, here's, we're zooming in a little bit more. Again, the scale is 14 kilometers across. And the other day when I was starting to put this talk together, I really had a chuckle to myself, or I guess as all the next gen would say, an LOL. When I saw this impact melt that was splashed out of the crater, because it reminded me of the day that I met Mike. And that we had a meeting in NASA headquarters in some ridiculously small rectangular room. It was like 2 feet on either side of a table. And the room was full. There was about 10 people in there, and there were 10 chairs, but there's only 9 people there. But of course, the 10th chair was on the opposite side of the table. So Mike, always a dominating force for good, when he walked into the room, had this big leather briefcase type thing that he had, and a binder, and a giant cup of coffee. And so he had to suck up, walk around, go all the way around to the other side, getting behind people. And when he finally was able to get down in his chair, as he was putting all of his stuff down, that giant mug of coffee went. I was sitting exactly across the table from him, and it was much like this crater, this tidal wave of impact melt. Coffee came across the table. Fortunately, I was able to push my chair back in time, and all went down on the floor. But that was just a WARGO story that, and of course, he felt terrible, but we all laughed about it and liked to joke about it for years afterwards. So that's the WARGO coffee spill. Here's, as we zoom in closer and closer with the LROC images, there's all sorts of geologic landforms related to impact melt. Here's a crater that formed, it's about 150 meters in diameter after the impact melt hardened, because you can see the eject on it, and it gives you insight into how craters form on coherent materials relative to how they form on granular ejecta. Here's where impact melt sloshed up and then came back down and formed what we have called fences. We've seen these in many different places on the moon. I think the most famous example is in the Highland Ponds, which I remember talking to Mike about that. It was a bizarre discovery, which we now believe is impact melt from Tycho crater on the other side of the moon. And again, you can see all the small little impact craters that formed subsequently, but I know we're running way behind, so I'm just going to skip on a bit. Again, here's that link if you want to go to Quick Map and explore WARGO crater in more detail. What we're seeing right now is about 5 kilometers in diameter. Here we've gone all the way down to the full resolution of the SNAC image. Okay, Michael was always positive, no matter what happened in the meeting, and he was always paying attention. I don't know how many of you have been in long NASA meetings that last all day and your mind starts to wander off into the weeds somewhere, or I've never done this, but you actually start to nod off. That was not Mike. He was always paying attention. And I think I have a couple minutes to tell this fantastic story about, this was at the LROC Preliminary Design Review. And I was a new PI. So I was somewhat nervous. Are we actually going to pass this review? Because if you don't pass the review, then that means that the, potentially would mean that the instrument gets canceled and it's not going to fly. So one of the engineers at MS Cubed, who's incredibly competent, got up there and he was talking about the electronics that run the LROC experiment. It's the SCS. And that there was a worry that it was sensitive to radiation hits, would result in single event upsets, causing the camera to go into a stupid state. But it wouldn't damage anything. And so our strategy was just to power cycle the camera every orbit, which is every 2 hours. And that way, if the camera did go into a stupid mode, it would recover and everything would be fine. And the worst case scenario is we would lose 2 hours at the most of imaging. And someone in the review panel asked this engineer a very pointed question in a very pointed way. Aren't you worried about damaging your instrument by power cycling it so frequently? And this incredibly competent engineer from MS Cubed, I think, took exception to the question. And he crossed his arms and just kind of stared at the floor about 20 or 30 feet in front of him, and he was turning beet red. And I'm sitting in the back of the room thinking, oh my God, what's going to happen? Have they exposed a flaw in the design? What is this engineer going to say? So finally, after what seemed like a day, but it was about 30 seconds, the response was, don't you think you really ought to be in a different line of work if you design an instrument that's damaged by power cycling? He didn't look at anybody. And after that, the room was dead silent. You could hear a pin drop, and I'm sitting in the back of the room melting, right? Oh no, he just sank us. And of course, Mike, I can't remember what he said, but it doesn't matter. But in his usual positive way, he spoke up, said something that caused the whole room to erupt in laughter, not making fun of anybody, pointing out some positive aspect. And we just moved on, and it was not an issue, right? And he did that repeatedly. That was his role. One of his big roles in these meetings is to keep the ball rolling. It was just, a wonderful part of his personality. Okay, and then, again, these endless meetings, there he is, again, always paying attention, always asking, insightful questions and keeping the meeting rolling. This was back in 2008, I believe, when we were working on this LMMP project, which was to take data and make maps, which is still ongoing today, 12 years later. Okay, Mike and I really saw eye to eye on a lot of things, and he joined the project. I can't remember the year, but it must have been 2006 or 2007. But one of the things that we really like to talk about and agreed on is that there was this artificial division between NASA's exploration side and the science side. And back in those days, the human exploration side was actually called ESMD, Exploration Systems Mission Directorate. And then the science side, as it is still today, the SMD, or Science Mission Directorate. And ever since going back into the NEAR project, it was always on my mind that it seemed like there was this engineering side of the fence and the science side of the fence. And there wasn't a lot of opportunity for them to speak. And that was a lot of it, was understandable. It was just the way institutions are set up physically, and also budgets are set up. But I had this great experience on the NEAR project where I was given complete freedom at APL. I was a free-ranging scientist. Even though I did not work there, I spent a huge amount of time there while we were doing the NEAR mission and while we were developing the messenger mission. The messenger proposals. And I spent a huge amount of time knocking on doors, sitting in engineers' offices, asking them questions about how does this work? And they were always incredibly patient with me. It was like, oh, a scientist, you're interested in what I do? And so that's how I became sort of a junior engineer. And it's been really great for my career because it really helps me understanding how to think about missions in a realistic way and how to get the questions answered. So this, when LRO started and I was trying to come up with a logo or a patch, as people like to call it, for the LROC experiment, it was a group effort with the team. I always try to do things as a group effort, but I had a few ground rules of what was going to be on the patch. And one of them was science enables exploration and exploration enables science. Remember, this goes back to the ESMD versus SMD days. And I really wanted to emphasize the fact that this mission, this LRO mission, was the epitome of what I had wanted to happen, was the merging of ESMD and SMD, because ESMD was paying for the mission and they built the spacecraft. And after a year, they turned it over to the science side, which is SMD. So it was really a fantastic opportunity. And then when I was looking at patches from the Apollo era, some of my favorite slogans, logos or whatever, were in Latin. So we translated that thought into Latin, and that's how that got on the patch. And Mike that really resonated with him, and he liked to use the science enables exploration, exploration enables science in public talks and in NASA meetings and so on and so forth. And so that's really the story of where that comes from and how much Mike and I got along. And it's not only just Mike and I, it's the LRO project. He really took to heart what LRO was doing, which is supporting a human return to the moon and enabling NASA to work towards getting the most science out of this return to the moon. And, you know, the LRO project really appreciated his tireless and positive efforts, and we certainly miss him dearly. But we've come full circle now. LRO is again providing key observations for human return to the moon. And as an example of that, this picture just came down a month ago, 8th of June, 2020. This is the Shackleton-Deger-Latch Ridge. You know, somewhere in here, I think that's the most, I was going to say logical, but I don't want to use that word, most popular thought for where the landing site will be, somewhere on this ridge, which, you know, maybe on the other side, maybe right here. But the fact remains that due to LRO, we have the data, and also the other international missions that have been returning data for the last decade. We have the ability to really make smart decisions about where to go. So the science that we've returned from the LRO mission is really enabling this return to the moon, this human exploration of the moon. So it's very gratifying to me, and I wish Mike were here to see that we have come full circle. And with that, I will call it a talk. Thank you very much, and thank you for the award.
Great. Thank you. Thank you so much, Mark. Congratulations to you and Harry both. And thank you for sharing the story about science enabling exploration and exploration enabling science. That is really the foundational principle on which our institute is based. So it's great to hear that. And I have a lot of Mike's stories as well, but I won't share them in the interest of time. So thank you, and congratulations to both of you. So I would now like to introduce the final award, and it's the Eugene Shoemaker Medal. Before I do that, I'm just going to mention that I'm quite aware that we're late, and what we're going to be doing is taking time out of the breaks and shifting things to the right a little bit. So we will adjust when we get to the sessions. So the Eugene Shoemaker Distinguished Scientist Medal is the final award of the day. and it's named after American geologist and one of the founders of planetary science itself, Eugene Shoemaker, who lived from 1928 through 1997. This year, it's awarded to Bradley L. Jolliffe for his significant scientific contributions throughout the course of his career. And the award includes a certificate as well as a medal with the Shakespearean quote, "And he will make the face of heaven so fine that all the world will be in love with night." Dr. Bradley L. Jolliffe is professor of Earth and Planetary Sciences and director of the McDonald Center for Space Sciences at Washington University. He received his doctorate from South Dakota School of Mines and Technology, and his research is focused on the study of minerals and rocks of the Earth, Moon, Mars, and meteorites, and what they reveal about conditions of formations and planetary processes over the past 4.5 billion years. As a member of the LRO camera science team, he investigates the surface of the moon, relating what can be seen from orbit to what is known about the moon through the study of lunar meteorites and Apollo samples. He's made significant scientific contributions in sample analysis, surface science, and remote sensing, as well as laboratory studies. Professor Jolliffe also leads the Washington University team that is part of NASA's Apollo Next Generation Sample Analysis program that you heard about earlier. SSERVI is very pleased to present Professor Jolliffe with the 2020 Eugene Shoemaker Distinguished Scientist Medal. Congratulations, Brad.
Thank you, Greg. Let me see if I can share my screen. See somebody, here we go. And, oh, I got to stop sharing to get my video on. And presenter view. Okay, quick sound check and video check.
Gotcha.
Okay.
You're actually not in the presentation view, you're in the presenter view. So you might want to change that.
Let's see if we can get it to. Okay.
Slideshow, yeah, that should do it. Oh.
Just hit the swap displays button at the top of that screen.
Hit the which button?
Swap displays.
Oh, I see what you, yeah, I think I know what the problem is. So sorry. Try one more time. Let's see. Well, that probably isn't doing it yet, right?
Yeah, that was looking fine.
Yeah, that looked good.
Yeah, hang on a sec though. So sorry, let me see if I can do this. Let's see, is it sharing now?
Not yet.
No.
Let me try this one more time. How about, well, what do you see now?
Just seeing you.
So sorry.
Not seeing a screen. You can go to one of the other views. That's okay.
Yeah, let's see if we can get it going now. I think if we do this and then at the top.
There you go. That's
it's looking fine now.
That's good.
Oh, okay. You can see that. Okay. Yeah. All right. Well, thank you very much, Greg. And thanks very, very much to the nominators and the awards committee. I'm totally honored and I'm totally humbled by receiving this award. Just in thinking about those who have won the award before me, they're all my heroes and they're all wonderful, wonderful people that I look up to. There's a picture of Gene Shoemaker that I love. He's sitting at the microscope there. Gene challenged us in many ways. He was persistent. He never stopped exploring. Don't forget your roots. And just really a wonderful person. I got to meet Gene when he visited Washington University in the early 90s to give a distinguished lecture. And I count it as really, he's one of my great heroes. I'm going to, and I should mention that last year's recipient, Harrison Schmidt, Jack Schmidt, again, one of my great heroes, and one who I count myself very fortunate to have been able to meet and work with in my career in a number of different situations. And that sort of leads me to what I want to say in these remarks. The real reward of doing science is not great research. It's not the great discoveries that you make or the publication count that you get. It's the people that you're fortunate enough to meet and to work with and to call friends and colleagues. So let me just go back and say that when I first got into this game, I was working on terrestrial projects. You can tell that this is not the moon. The little inset there shows a huge tourmaline spray and a rare element pegmatite in the Black Hills. This was not the moon. But my advisor as a graduate student, Dr. Jim Popike, led me in, he gave me the start, I think, of an interest in the moon in talking about the use of minerals such as pyroxene as recorders of petrogenetic processes. And I really came to love that. And you could see another person there I worked with, young research scientist working with the group at that time, none other than Chip Shearer. So I was very fortunate to, and I also want to indicate that there's some serendipity here. I was not necessarily looking to work in planetary science, but the opportunity came up to go and work with Larry Haskin and Randy Korotev at Washington University. So Larry was my postdoc mentor. There he is in the upper right. Wonderful, wonderful person. Passed away in the mid 2000s, and we dearly miss him. And there's Larry and Randy together at a photograph in the Black Hills on a field trip. I learned a tremendous amount from these two and still work with Randy. We've been working together now for over 3 decades, and it's just a wonderful, wonderful relationship. Okay, so at Washington University, I got to work with some other young scientists whose names you will recognize. Mark Wazarek, who as a grad student with Roger Phillips, brought geophysics to our group, along with a fierce loyalty to the moon that even Roger had trouble understanding. Jeff Gillis, now Jeff Gillis Davis, who had worked with Paul Spudis and the Clementine mission, came our way and introduced me to lunar photogeology. And we got involved in working with the Lunar Prospector mission and the likes of good friends now like David Lawrence, Rick Elphick, and Tom Prettyman. Then I got my introduction to working with remote sensing data through a collaboration, again, serendipity. I got hooked up with Paul Lucy and Dave Blewett, looking at Clementine data and trying to correlate the orbital data to ground truth samples. So we were looking at the iron and titanium mapping effort in these times. And this led to a long-standing collaboration with this fellow shown in the lower part there, Mark Robinson, who you've just heard from. And of course, I've later had the good fortune to become part of the Lunar Orbiter Camera science team, and that's been fantastic. Great group of co-Is, researchers, and students. Then this fellow in the upper right there, Ryan Ziegler, now the Apollo Sample Curator at Johnson Space Center. He was Larry Haskin's last PhD student, but he worked alongside Randy and me, developed a love of working with the lunar samples, Apollo samples and lunar meteorites that rivaled even my own, and in fact surpassed my own, I think. Ryan and I got hooked up with wonderful colleagues in Beijing, and you see the paper in the lower part there, and Professor Dunyi Liu, who runs the Beijing Shrimp Center, and had a really great collaboration that continues to this day. And this was introduced to us by my longtime colleague at Washington University, Professor Alian Wang, who, by the way, joined our group when I was working with Larry Haskin to show us that we could use laser Raman spectroscopy to explore lunar mineralogy. So the Moonrise mission proposals, I have to mention something about this. Moonrise consumed almost 2 decades of my life, I think, but this was another great highlight of my career, owing to the fantastic group of scientists and engineers that I got to meet and work with closely at the Jet Propulsion Lab, working with Lockheed Martin. Whether or not we got the mission, this was just a wonderful group of individuals to get to work with. And you can look down through those names and you see quite a few. I would just point out that some of the individuals, such as Carly Peters and Jim Head at Brown University, have just been longtime collaborators. And I think I've gotten to know each and every one of their students who have graduated with them. Fantastic group. And I would be remiss if I didn't mention the great group of engineers at JPL, led by this fellow, Dr. Leon Alkali, a great friend of the moon and a great friend of Moonrise. So now we come to sort of the best part, the best reward for somebody who has hair that is turning the color that mine is. In the past 10 years or so, I've had a wonderful, wonderful group of students that I've been fortunate enough to work with. Steve Sedio, highlighted here, took up my love of granite, lunar granite that is, and worked on these samples. There you see a beautiful lunar granite on the left, backscattered electron image in the middle. And on the right, the results, Steve used the electron microprobe to date uranium lead age dating 3 different minerals in one of the granite samples and actually got a concordant age at around 3.9 billion years. So that's fantastic. The other thing that has really been great for me is having a wonderful lab manager in the electron probe lab, and that's Paul Carpenter. So then moving on, here you heard from Ryan Clegg Watkins earlier today. Ryan came to Washington University with an intense focus on the moon, a love for the moon, and got into working on the photometry of the blast zones around the Apollo landing sites. Who knew we would get into such kinds of things? Mike Zanetti came and got our group into crater counting, thanks to another person you've heard from, Harry Hiesinger, and there's Carolyn Vanderbogert as well, who trained Mike and then sent him our way. Juana Coleman, she followed up some of the LROC studies on the titanium content of the moon using LROC data by using some laboratory spectral analysis. Very nice work. And then Sarah Valencia. Sarah has an unparalleled love of sample analysis, especially with the electron microprobe, and she made the Northwest Africa 773 clan meteorites her thing and published a beautiful paper on this. And she's also doing some tremendous work on another beautiful Apollo sample, 12013. Catherine Shirley, upper left there, was an undergraduate working with me on LROC projects and actually took up the challenge to determine the age of the Compton-Belkovich volcanic complex. Catherine recently finished her PhD with Tim Glotch at Stony Brook. Amanda Stotterman, also working as a graduate, as an undergrad at the time, but now at the University of Arizona, took on the reanalysis of the youngest basalts south of the Aristarchus Plateau, the P60 region. Very, very nice paper. And then again, at the bottom, you see another of Ryan's papers and a list of co-authors that includes some of the LRO team, Tom Jaguar, Julie Stopar, and Sam Lawrence. We've just benefited so much from having this great group of collaborators. Then I would just say at the very end here, to my friends and colleagues and all you lunatics, thank you so much. And I would just also add that for my current students and recent students who graduated a year ago, Michael Bouchard and Tim Hahn, also current students, Emily Cully and Chris Yen. This is just the best that you can have when your students are so wonderfully independent And I just, wish them all the best going forward, and all of you folks. And let's get back to the moon. Thank you.
Thank you so much, Brad, for another wonderful talk, and congratulations on receiving this medal. And one thing that I can reflect on quite briefly here is that in each of these talks, there's been a theme, and that's that it's all about the people. So all of us here are interested in these things, but we all support each other. And I'm not a lunatic by training, but I have been adopted, I suppose you might say, and I love this community, and it's just such an honor helping support it and working with all of you fantastic people. So congratulations again to all the awardees.